Okay, so how in the world do you explain a number that means less than nothing to a room full of sixth graders? I mean, it's a concept that's so abstract, right? You can't see it, you can't hold it, so how do you make it click? Well, today we're going to break down this absolutely brilliant lesson plan that turns this abstract puzzle into a physical, totally intuitive reality. Let's get into it.
Everything kicks off by challenging a core assumption. For a young student, 0 has always been the beginning, the floor, the end of the line. But what if it isn't? What happens when you ask, what if 0 isn't an edge but a center? This one question, right here, is the key that unlocks the door to a whole new dimension of numbers.
So before you can just hand someone a map, you've got to make them curious about what's over the horizon. The first move here, and it's a smart one, isn't to just give them answers. It's to spark questions that make students actually rethink the nature of a line itself.
And the genius is right here. The lesson doesn't start with some boring definition. It starts with a conversation. By just asking, hey, where does the number line begin? The teacher kind of nudges the students toward this really profound realization. Maybe it doesn't. Maybe it just goes on forever, in both directions.
So now their minds are open to this idea, this possibility of a world to the left of 0. But how do you make that space feel real? This is where the lesson gets truly brilliant. It gets kids out of their heads and literally onto their feet, turning an abstract idea into a physical place. That's right, I'm talking about a giant number line made out of masking tape right there on the classroom floor. Students don't just look at the numbers anymore, they physically stand on them. They become the number line. It makes the math an active, physical experience.
And to give that empty space some real meaning, the lesson uses an anchor that everybody understands: time. The present moment? That's 0. 3 hours from now is pretty simple. That's +3. So then, where would you stand for 3 hours ago? All of a sudden, the answer is just obvious.
And that is the click. That's the big aha moment of insight. These negative numbers aren't some weird mathematical fiction anymore. They're yesterday. They're what came before. That empty space now has a real intuitive meaning that every single student in that room can actually feel. So once that gut feeling is established, then you can build the language around it. And the language of this new expanded number system is all about this elegant, perfect symmetry. It's all about mirrors.
Just think of 0 as a perfect mirror. Every single positive number you know and love has an identical reflection on the other side. And that reflection, that mirror image, that's its negative counterpart. See, it's not really a new type of number, it's just the other side of the same coin.
And this leads us right to this super important piece of vocabulary: opposites. Two numbers are opposites if they're basically just staring at each other across 0, standing the exact same distance away. It's a relationship based purely on position and symmetry. Pretty cool, right?
So what do 4.5 and -4.5 really have in common? It's their distance from 0, their magnitude, their size. It's identical. It's a 4.5-unit journey from the center. The only difference is the direction you decide to travel. And let me tell you, grasping that one distinction, that is everything. Okay, so the students now have that physical feeling and the official language down. The final step is to show them that this new math isn't actually new at all. It's been hiding in plain sight their entire lives. What's so powerful here is seeing how the meaning of 0 can shift. When we're talking about money, 0 is breaking even. In temperature, it's the point where water freezes. For elevation, it's sea level. See, 0 is just our chosen starting line, and negative numbers give us this amazing way to talk about everything below it: debt, freezing cold, and the depths of the ocean. And here's the connection that really makes it all stick. What is a thermometer? It's just a number line that we've turned on its side. And suddenly, negative numbers aren't some weird abstract idea from a math book. Students realize they've been reading them this whole time, every time they check the weather.
So why does one little lesson on negative numbers matter so much? Well, because it isn't just about adding more numbers to the line. It's about building the foundation that unlocks entire new branches of mathematics. Look, the goal here isn't memorization. It's about gaining new mathematical superpowers, the ability to compare and order any number, the insight that absolute value is just pure distance, completely stripped of direction, and the skill to use this whole system to solve real-world problems. And this is the ultimate payoff. Remember that simple, elegant idea of reflecting a number across the mirror of 0?
Students will use that exact same move later on to reflect an entire two-dimensional quadrant, and that's how they create the four-quadrant coordinate plane. So you see, this one lesson doesn't just explain a line. It builds the entire stage for algebra and beyond.
Ultimately, this whole thing just shows that the most profound teaching isn't about downloading facts into kids' brains. It's about building these conceptual ladders that let us all climb to new heights. Which, leaves you with a really fascinating question. What other simple key is just waiting out there to unlock a universe we haven't even seen yet?